In this section, you're going to find the area of triangles and parallelograms. Let's just briefly understand what we mean by area. Area is all the shaded part of this parallelogram. So let's do that. This is area. Area is two-dimensional. Length is one-dimensional. The way we find the area is by using the lengths of the sides, or we find the altitude or height of a parallelogram, and then we find the area. So let's talk about, let's say this is area. What's the area of a square? A square, as studied in the section of quadrilaterals, is a quadrilateral with congruent sides. So if I call one side S and the other side S, the area of a square is S squared. Area congruence postulate. If two polygons are congruent, they have the same area. So if I was to say a polygon could be any shape, let's say I have a triangle and a triangle, and these are congruent. If I know the area of triangle 1 is 40 units squared, then I can conclude the area of triangle 2 is also 40 units squared without having to find it. Area addition postulate. So let's say I have a figure like this. I have a circle and I have a rectangle. If I want to find their combined areas, then I take the area of the circle, area of the rectangle, and I would add them. That may not be the perfect example. So let's take one triangle and another triangle together. They form a parallelogram. You would add the area of triangle 1 and the area of triangle 2 equals area of the parallelogram. Area of the rectangle is base times height. So usually we call the horizontal side the base and the other one height, although there is no reason why you could do it the other way. The area of a rectangle, and rectangle opposite sides are congruent, area is base times height. A parallelogram is really a tilted rectangle. If you look at these sides here and you imagine them sort of leaning to the right, if the whole parallelogram was made of sticks or something, or if the whole rectangle was made of sticks, then it would still have the same area, but what you would have to do in this case is, if this is the base, you need to find the vertical, you need to find the height, which is not the vertical but the perpendicular distance between the two sides. So in this case the height is that perpendicular dashed segment. So area is still base times height. It is not base times the side length. I just want to point out to you that we could also, the same one, if this was the base, then this is a terrible diagram, but this is the height. Okay? So either one of the sides can be the base, but the height is a perpendicular distance between the two sides. Area of the product of and its corresponding height. So you have three scenarios here. You have an obtuse triangle and this is the base from here to here. The dash, I'm dashing it so you can see. Maybe what I would have been doing is highlighting it, so let me highlight the base in each case. Base, base, and base. In an obtuse triangle, depending on which side you use as a base, the height can sometimes fall outside the triangle. So this is the height, and the height, and what I need to show here is that these are right angles. Height, height, height. This is obtuse, acute, and right. In a right triangle, the legs can be interchangeably called the base and the height. It doesn't matter. In an acute triangle, the height may or may not fall inside depending on which side you use. In either case, the area of a triangle is base times height of 2. And it makes sense. A triangle is half a parallelogram, so its area is half that of a parallelogram. This is a pretty easy section. It says area of RSTU. So what you need to ask yourself is, what would you use as the base and what would you use as the height? There may be redundant information. You have to figure out which is redundant or what is it that you don't need. Question number 2. The base of a triangle is 1/2 the height. The area is 64 square feet, base and height. What you could start out here is say, let the base equal to x, and so the height will be double that, it'll be 2x, and then use your formula, so plug it in and solve. Alternatively, you could say the height is h and the base is half h, and solve it that way. Either way, you'll get the correct answer. Two triangles have the same base and height. Must they be congruent? I want you to draw these triangles out and draw 4 or 5 and see if you have a pattern, whether they have to be congruent. And that goes for 3B as well. Okay, number 4 is interesting. You need to buy paint so you can cover the back of an A-frame house and the top of the deck. So the deck is at the bottom, the house is sort of vertically, it's a triangle. How many gallons should you buy? So a gallon covers 275 feet. It seems to me that you would have to find the area of the triangle and the area of the rectangle, add them up, see how many square feet it is, and then figure out the number of gallons you would need. Right, and these are the answers. So good luck.